So today we will be talking about vectors, which is section 7.3, and of course I am Mrs. Thompson. Here are our objectives for today. You may pause the video and read these more carefully. The length of a vector represents its magnitude. So, for example, a vector with a longer length represents an object traveling faster. Vectors also have a direction, expressed by an angle measurement. Using an illustration to deepen our understanding of vectors. Two horses are pulling on a tree stump with forces of 200 pounds and 300 pounds, and an angle of 65 degrees is between the forces. The 200-pound force is formed by the first horse pulling on the stump. The 300-pound force is formed by the second horse pulling on the stump and is represented by vector B. Vector A is the horse pulling with 200 pounds of force. If these horses were pulling in the same direction, then vector A plus vector B would total 500 pounds of force. However, they are not pulling in the same direction. However, this blue line, which is a diagonal, represents the force of horse A plus horse B. So it is the sum of vector A and vector B because they are not pulling in the same direction. So the single force A plus B acting along the diagonal is called the sum of vector A and vector B. It can also be referred to as the resultant of vector A and vector B. Now looking at adding and subtracting vectors graphically. To find the sum of vector A plus vector B, to find the sum A plus B of any vectors, A and B, we find the vector that begins at the initial point of A and terminates at the terminal point of B. Notice in the diagram that terminal points have arrowheads and initial points do not. So, adding vector A and vector B with this first example, starting at the initial point of vector A, drawing a vector to the terminal point of vector B, we now graphically represent in blue vector A plus vector B, that sum. Looking at subtraction, which is just adding the opposite by definition, we're going to add vector A and vector B, but this time vector B is not moving upward or traveling upward in the positive direction. It's traveling downward in the negative direction. So our problem will end up being subtraction. Still, same procedure as the previous example. We start at the initial point of our first vector, vector A, and travel to the terminal point of vector B. And because B is moving in the negative direction again, this represents A minus B. Looking at the component form of a vector. So using component form to identify a vector. The notation A comma B inside the symbol for component form, which looks like a less than and greater than symbol, or V opening to the left and another one opening to the right. It's used for the position vector with terminal point AB. The magnitude of this vector is equal to the square root of a squared plus b squared. The formula just shared was how you find the magnitude of a vector given in component form. Finding the magnitude of the horizontal and vertical components. So looking at an example of this. First, the formula for the magnitude of the horizontal component is the absolute value of r times the cosine of theta. And the formula for the magnitude of the vertical component is r times sine theta. And again, you take the absolute value of that product. So first, for finding the magnitude for the horizontal component, r is given to us to be 8.3. So we just multiply that by the cosine of the directional angle, which was given to us as 121 3/10 degrees. You would use a calculator to find this cosine, multiply by 8.3, and make sure your answer is not non-negative. If it is negative, make sure you drop the negative sign. Using basically the same procedure to find the magnitude of our vertical component, except for this time you use the sine function. So you find the sine of your directional angle, using a calculator, multiply that by 8.3, and make sure you write your final answer in a non-negative manner. In this example, we're finding the magnitude again, but this time our vector is given to us in component form. So we have to use the formula for finding the magnitude when we have component form that was shared on slide 7. So the first value is our A value, the second value is our B value in component form. So just plugging in the values for A and B, doing what the formula says, squaring the A value gives us 4. Squaring our B value of -5 gives us 25. 25 plus 4 gives us a final answer of the square root of 29 for the magnitude. And now for an example of finding the directional angle. So how do we find the directional angle? To find the directional angle, use the trig ratio. The sine of theta, or the sine of your angle, equals B over R. So remember, R is your resultant, which is also your magnitude. So we have the value of R here because this was our magnitude. After doing that, take the inverse. So substituting into our formula, our B value is -5. It was given. R, we just calculated it. It is our magnitude, the square root of 29. So substituting that in. And then to find the angle measurement, of course, we pull out our calculator and just take the inverse sign of -5 over the square root of 29. We're almost finished. It gives us a value of -68 2/10. However, we know that this vector terminates at the point -2, -5. So in other words, this point is in the third quadrant, so the angle is in the third quadrant. So we need to get our angle in the third quadrant by subtracting -68 2/10 degrees from 180 degrees. For a final answer, we have our directional angle. It is 248 2/10 degrees. A couple of facts to know about perpendicular and parallel vectors. Two vectors are perpendicular if their dot product equals 0. And two vectors are parallel if the cosine or alpha or the cosine of the angle equals +1 or -1. Here are the formulas for calculations of vectors in component form. The dot product mentioned on the previous slide, the formula is here. To find the dot product of two vectors in component form, you multiply the first component of both vectors and add to that what you get when you multiply the second component of both vectors. We also see that we simply distribute to both numbers inside the parentheses if we have to multiply it by a scalar amount, by some number. We have formulas also for adding and subtracting. We see to add, we add the first components of both vectors and then add the second component of both vectors. To subtract, first component of both vectors we subtract, a sub 1 minus b sub 1, and then we subtract the second components, a sub 2 minus b sub 2. We will be using some of those formulas in our final problem for today. Finding the angle between two vectors. To find the angle between two vectors, use the dot product theorem, then take the inverse cosine. So here is the dot product theorem. So let's go ahead and jump right in. Here are our two vectors given to us in component form. So our numerator tells us to multiply, A times B, vector A times vector B. Here's the formula from the previous slide. So multiplying first component of A, -1 times 2, adding to that what we get when we multiply 5 times 7. That gives us an answer of 33 for our numerator. The denominator is asking us for the magnitude based on what we have. We have to use the formula a squared plus b squared and then take the square root. So -1 squared plus 5 squared. And take the square root of that would be the square root of 26. Doing the same thing for our second vector, we get the square root of 53. Now that we know what the cosine of the angle is equal to, pull out your calculator, take the inverse cosine of 33 divided by the square root of 26 times the square root of 53 for a final answer. Round to the nearest tenth for the directional angle of 27 3/10 degrees.